Today we're going to start learning about area and kind of the first step in finding areas of shapes like the ones you see below here. We're not going to be able to figure this out exactly today, but if you manage to sleep tonight knowing this, we'll figure out how to find the exact area of this tomorrow. And other shapes like this, between curves, just odd shapes that we don't have normal formulas for. We're going to use some calculus to figure it out. But in the meantime, we're going to start off pretty basic and using rectangles to approximate area of these types of shapes. So you see down below here, it says Riemann sum. And there's three different types of Riemann sums that we're going to look at: left hand, right hand, and midpoint. Well, basically a Riemann sum, and we're really just kind of looking at a basic definition here. Basically, we use rectangles to approximate the area of a much more complicated shape. Yes, it's all going to tie back together. So we're using rectangles to approximate the area of a much more complicated shape. So yes, the integrals, antiderivatives are going to tie in with this. The stuff we did yesterday with sums is going to tie into this. There's lots of stuff that all kind of ties into this area. It's a pretty big concept. But today we're kind of starting off small, taking that first step towards figuring that stuff out. So in this process of using rectangles to approximate area, like I said, there's three different possibilities here: left-hand Riemann sum, right hand, and midpoint. So with this first one, a left-hand Riemann sum, we're going to take this graph. We have the equation up here, y equals 4x minus x squared. That's the equation of this graph. And a lot of times we'll use the term find the area under the curve for stuff we're going to be talking about. What that means is find the area between the graph and the x-axis, so kind of that highlighted region that we see there. So in this case, it's going from 0 to 4. And with Riemann sums, we can break the big area into little subintervals, right? Little portions, right? We're going to break it into those rectangles. So the number of rectangles we use changes, it varies. For this one, let's go ahead. What we're going to do is make a rectangle every 1/4 of a unit. Right, so like basically every time we have one of these vertical lines on our coordinate plane, what I want you to do is just go ahead and draw, for now, just the vertical line for our rectangles. All right, so what we've done there is we're breaking it up into 16 little parts. And in this case, each one of those parts, although they're going to be different sized rectangles, they're all going to have the same base. Right? They all have a base of 1/4. Each one of them will have a base of 1/4. Now, how we draw these rectangles is determined by what kind of Riemann sum we're dealing with. In this case, we're asked to use a left-hand Riemann sum. What that means is we're going to use the left side of our little subintervals to find the height of each rectangle. So for our first subinterval, we go from 0 to 1/4. Well, sorry to say it's a little bit of a letdown, because the left side at 0, if we take that and use that as the height of our rectangle, we have no rectangle. So really nothing happens there. But then if we look at from 1/4 to 1/2, we've got right here and here. Since it's a left-hand Riemann sum, we're using the left side as our height. So we're just going to draw a line horizontally at this point. So when x is 1/4, whatever that point is on the graph, that's where we're going to go horizontally to create this rectangle. Then from 1/2 to 3/4, again, we're using the left side to create our height. So out of those two vertical lines that we've drawn, the left one is going to be the height of our rectangle. Then from 3/4 to 1, again at 3/4, and so on. So the left side, we can kind of just draw our line horizontally over. And what you'll notice is as we go over that vertex, to the right of the vertex, now our rectangles end up being partially outside of the graph. So what we end up doing is using area of all of these rectangles to approximate the area of that highlighted shape that we had. So it's obviously not going to give us the exact answer, right? Because over here on the left you can see there's space missing that we didn't account for. But then again on the right side there's space that we accounted for that's not under the curve. So maybe it balances out a little bit and gives us a decent estimate of the actual area. Alright, so today we're just looking at estimating. Tomorrow we'll actually find the exact area stemming from what we're doing today. Well, to save us a little time and effort, for these other two I'm not going to break it up into 16 parts. Let's just break it up into 4 parts. So from like 0 to 1, 1 to 2, 2 to 3, and 3 to 4. If we do a right-hand Riemann sum, that just means we're going to use the right side of the interval. So from 0 to 1, we're going to look at 1, put 1 into the function. We get this point on the graph, 3. Right? We can see it pretty easily in this case because we have a nice value. But really all we're doing is plugging it into this equation. 4 times 1 minus 1 squared, that's 3. That gives us our height. Then from 1 to 2, we put 2 into the function, we get 4, and that's going to be the height of this next rectangle. From 2 to 3, put the right endpoint in, put 3 in, we get 3 out. That's going to be the height of our rectangle. And then if we put 4 into the equation, we get 0 out for y, so there is no rectangle there. And then our last one is a midpoint Riemann sum. So let's stick with just kind of breaking it up into 4 parts. Oops. But obviously rather than using the left endpoint or the right endpoint of that interval, we're going to use the midpoint. So between 0 and 1, 1/2 would be our midpoint. So if we go up to the graph at 1/2, or if we plug 1/2 into this equation, we get the height of our rectangle. From 1 to 2, if we put 1.5, so if we look at 1.5 go straight up to the graph, that's going to be the height of our second rectangle. Put 2.5 in, that's going to give us the height of the third rectangle. And then put 3.5 in, and that's going to give us the height of the last rectangle. So those are the 3 different types of Riemann sums that we'll be using. A lot of times in the AP tests, like those questions, you're going to see Riemann sums. Usually you're only going to break it down into 3 to maybe 6 parts. All right, and they'll do that just to kind of check to see that you understand the concept and what you're doing.